Now, the very first thing that we focus on is quantitative aspects of chemical change. Quantitative aspects of chemical change. But now, what is this quantitative aspects of chemical change exactly? What we want to do with this topic is us being interested in quantities, or basically just quantity. So what it says to me is I should be in a position of calculating how much of this specific substance do I need in order for me to have this much. So basically everything that we do will be based on quantifying, having a specific amount that we need to use when we are experiencing what we call a chemical change. So what is chemical change? Chemical change, it basically says it's chemical reactions. Chemical reactions, we use them in order for us to have now the specific quantities that we want now to calculate or have a certain specific magnitude of them. But there's one rule that governs everything. And that rule that governs everything is what we call a mole. So a mole is basically a start-up point for us in order to be able to know what is it that we are going to work on, or what is it that we are going to be focusing on. The reason for that is if everything we relate to moles will assure us in order of any other physical quantities we have or chemical quantities we have will be based on the mole. So the mole is basically a key concept that now governs what we need now to know, because what is important from this is we must also know the definition thereof, which says now an amount of a substance having the same number of particles as there are atoms in 12 grams of carbon 12. So this is a definition that we need to know. So from this, it basically says to me, okay, let me check, something is on here. Okay, fine, there we go. So it basically says now, if I'm working with the moles, I'm basically interested in the amount of substance having the same particles as there are in 12 grams of carbon. But when you look at in the periodic table, the periodic table exactly tells us that the molecular mass or the atomic relative mass of carbon is 12. Basically, it says to us, we are going now to use the atomic mass of carbon as our reference point. So what we need to know here is basically the definition thereof. After the definition, what is key is the SI unit. So the SI unit will be now mole. This will be the SI unit. So everything that I calculate, and that relates now to the number of moles, the SI unit will be mole. There further on now, we are interested in the symbol, and the symbol thereof is just a small n. So this small n represents now in my equations the number of moles. So with this being said, it says to me, whenever I calculate different quantities, the reference should be the number of moles. So the number of moles is key. The number of moles is the quantitative aspect. But let's further move on and say on page number 2, I'm going to try now and build on each and every quantity that we have. So the very first thing is, I am interested now in calculating the mole, which is just mole. And let's say for this instance, it's just the mole of A. So the examiner, what can do is they can give me any kind of information for me to be in a position of calculating any form of information that I have. So I'm going to add few aspects that I feel that now we need to be focusing more on. So let's move on and say, if I am given this information, then I'm in a position of saying the examiner can ask me to calculate the number of moles using the formula N is equals to M over the molar mass. So what does this formula say? This formula says to me, I can use this now to calculate my mass, which must be in grams. I can use this now, this will be my molar mass, and this molar mass must be now in grams per mole. So this is the easiest way, or the first way of me now calculating the number of moles. But what is complex is, I must be in a position now to calculate the molar mass. So for molar mass, it basically says we need to go back and do simple examples of how one can calculate the molar mass, because the mass in most cases will be given, this one here. And remember, it must now be in grams. So this is the equation that one can use now to calculate the mass. So this is the equation that one can calculate the mass. So whenever I'm asked now to calculate the mass of a substance, it basically says to me, I need now to have the number of moles, I need to have the molar mass, then I will be able to calculate the mass thereof. So I'm going to give you 15 seconds for you to digest this so far. And then if you have questions, then I will take questions based on what we have spoke about right about now. If you don't have questions, you clearly say you fully understand. Thank you very much. Then let's go to the second aspect then. The second aspect is for us to calculate the number of moles again. We need now to have N, which is equals to N over NA. But what does this say to me? this says to me, this here can be any number of particles or even number of atoms. So we are going to take each and every one of them in such a way that we are able to use each and every equation that is given to us. And this here is what we call an Avogadro number. So this Avogadro number is a constant number or a constant value. And this constant value is the one that allows us to relate now the number of atoms with the number of moles, because the Avogadro number, as it is given as 6,023 multiplied by 10 to power 23, it basically says the particles per mole. So this is a number that indicates now the relationship between the number of moles and the number of particles. So this one here, we just say it is a constant. So it being a constant, it allows us to calculate for the number of particles. So every time when I'm asked for the number of particles, it says to me I should be focusing more on using my Avogadro number. So the Avogadro number will be a number that will be given because it's a constant that enhances now my understanding in terms of calculating for the number of particles. So with that being said, we will move further on to another one. Remember, the intention here is always try to get the number of moles. So to get the number of moles in this instance, the examiner can also say N is equals to V over Vm. But what is V over Vm? V over Vm basically says now this is a volume, and now this is a molar volume of a gas. Molar volume of a gas. And this is usually given as 22,4 decimeter cubed per mole. It is always given as that. But again, what does this say to me? It says to me my volume in this instance must be in decimeter cubed. So whenever I want to use this information or this equation here, the key thing to understand is my volume must be in decimeter cubed, 100%. So now, this is also a constant, 24,2 decimeter cubed. But be on the lookout if the examiner now decides to change the value depending on the temperature given or depending on the information that is given thereof. So this is another way, but we only focus on this one only if we are working with a gas. So before I can decide now to use this equation, the key idea should be only for gases. If it's not for a gas, then it says to me I am not in a position of applying this specific equation. So for me to use N is equals to V over Vm, I need now to be in a position of saying the equations that I am working with must just now be only for gases. If I am expected to calculate the volume and I must use now N is equals to V over M, definitely that must be for gases only. So be on the lookout for that, because most people, we do a mistake relating to this because we don't emphasize the issue that that equation is only used for when we have gases. So let's further move on, and we are still interested in calculating the number of moles. So I can calculate the number of moles using C is equals to N over V. Remember, in all the equations, N is basically just the number of moles. So in this instance, we have this one, we call it concentration. In this one, we also have our volume. But the key thing is our volume must be now in decimeter cubed. Once our volume is not in decimeter cubed, we are expected now to convert. But when we do exercises related to this, is then that we will be in a position of fully understanding. And our concentration is now mole per decimeter cubed. But when do I need now to use this specific equation? So this specific equation I can use if I have now gases and aqueous solutions. So if I have aqueous solutions and gases, definitely this equation will be able now to work. But the emphasis again must be that once I have an aqueous solution, do I have it the volume in centimeter cubed or decimeter cubed? If it is in centimeter cubed, definitely I must convert now to decimeter cubed. So this, when you check, it's basically the basic approach of the stoichiometric calculations. Because one will say, but what happens after this? When we get to a point of me fully explaining other things like percentage composition, empirical formula, it will be best if we fully understand what is happening on this specific slide. So what I'm going to try and do now is trying to use this equation for us to ensure that we are in the same line in terms of calculating the number of moles when we are given the mass. So I'm going to have a basic example here. But before the basic example, let me give you that 15 seconds for you to digest this. And maybe if you have any comments related to this slide, you can easily do so. Is everything still clear, Ratana? Yes, there is. Let me do it for you. Okay. If now you are given your volume in centimeter cubed and we want to take it now to decimeter cubed, you divide by 1000. So that is the easiest way of doing it. So remember that when you are given your volume in centimeter cubed, for you to convert it to decimeter cubed, you just divide by 1000. Thank you. Now I'm going to do few examples where now we try to calculate the number of moles, the basic ones, such that we know for sure that we are happy with number 1, number 2, number 3, and also number 4, because these are basic equations that we are going to need moving forward. So I just have to confirm that we are in a good position of calculating the number of moles, also number of particles, the volume thereof, and now the concentration. So let's move on. And the first one will be, we are only calculating the number of moles. So calculate the number of moles. It's as basic as that. Calculate the number of moles. For A, we are given 5 grams of sulfur. So if you are given 5 grams of sulfur, what is it that I need to do? I usually say, because the question says we must calculate the number of moles. Because the question says calculate the number of moles. In the 4 equations that I have, which equation now relates to the mass? The only equation that relates to the mass, that relates to the mass, is N is equals to M over M. So can I write all the information that is given in terms of the variables? Yes, I can. I can say N is what I am looking for. M is given, it's 5 now grams. And now I need to have the molar mass of sulfur. Where do I get the molar mass of sulfur? That is where now the key concept of having a periodic table comes in. So when I look into my periodic table, I have sulfur now as 32 grams per mole. So I have all the information that I need. So the easiest thing for me to do will be now N is equals to 5 divided now by 32, which will give me my answer in mole. So I'm quickly going to use my calculator, which I believe I have here. Okay, it is now 5 divided by 32, which gives me something like 0,15625 mole. So 0,15625 mole. So this is the easiest way. This is the basic of them all. Because remember, now I got the 32 by using the periodic table. The mass was now given. But now let's take it to a more complex question. For the more complex question, they say to me, it is still 5 grams, but now 5 grams of carbon dioxide. So what must I do in this instance? In this instance, it says now I have to calculate the number of moles. I have now the mass, which is just 5 grams, but I need now the molar mass of carbon dioxide. So how do I calculate for that molar mass? I take my periodic table, check the molar mass of carbon. The molar mass of carbon is 12. What is the molar mass of oxygen? It is 16. But how many atoms of oxygen do I have? I have 2 atoms of oxygen. So it basically says in this instance now I will be in a position of calculating the total molecular mass of carbon dioxide. And now using a calculator, it's very easy. It is going now to be 32 plus 12. This will give us now something like 44 grams per mole. So with this, everything now becomes nice and easy. I have my molar mass, I have my mass, so it's easy for me. It is going to be N is equals to M over M. Then it's 5 divided by 44. Then the final answer is 5 divided by 44. This will give me something like 0.1136 mole. And if the examiner wanted to allocate marks, obviously it will be 1, 2, 3, and then 1 will be in a position of getting the full 3 marks. So this is now becoming extremely basic. So I am going to give you this one, which is number C, of which we will discuss together once you are done with it. And we are just going to say it is now for 20 grams of sodium hydroxide. So remember, you must also calculate your final answer and just send your answer to the chat, or you can even send me an image of where you did it. So I'm going to give you a minimum of 2 minutes for you now to try and do this one on your own. Then we can move on. Okay, Ratanang, what's your answer? 0.5 mole. Okay, let's try and see if you got that one right. The only thing that I need here is for me to get the molar mass of sodium hydroxide. So from my periodic table, sodium is 23 plus 16 plus 1, which will be now 23 plus 16 plus 1 it's 40 grams per mole. And then I have M is equals to M over molar mass, which will be now 20 divided by 40. That's 0, 0.5. Ne? 20 divided by 40, 0, 0.5, 0, 0.5 more. Thank you very much for doing this one right. So let's take it a notch higher for us to ensure that we are in a position of closing all the gaps. So the second one, they say now we must calculate the mass. Calculate the mass. So for A, we are giving now 2,5 mole of H2O. Quickly do this one. I will give you something like 2 minutes also. Okay, let's make it a minute. This one is an easy one to do for you to complete it quickly. They say now calculate the mass. Thank you very much. What's your answer? Okay, I will give you more time. All right. It is 45 grams. Thank you very much. Let me quickly explain. I think you did it the right way. So basically, I always say, write the information that is given. I'm given the number of moles, and the question wants me to have the molar, to calculate the mass. So obviously, I need now to have the molar mass of H2O, which will be just 1 plus 2 multiplied by 16. This will give us now 18 grams per mole. Then write the equation as it is from the formula sheet. What you sent me yesterday, I saw that there was a point where they said the equation should be M is equals to N molar mass. Ne? So it is true, it is correct, yes, but the examiners don't want to accept this one. The reason for that is they want us to use the formula sheets that are given, or the formula sheet that is given with the question paper. So it basically says this equation is not in the formula sheet. Not in the formula sheet. So if it's not in the formula sheet, we always use now the formulas as they appear in our formula sheet. So the only way of you getting a mark will be writing this one first and then substituting into this one. So substituting into this one is just saying 2,5. I want the mass, and then I have my 18. Because when we mark this, we give a mark for the substitution being correct. So we'll give you a mark for this substitution. Then that you can manipulate it and just say, now I'm going to have 2,5 multiplied by 18, and my mass will be 45 grams. So remember, the SI unit is always important. I have taught a couple of learners that we have a principle we use which we call F sort. Ne? So I'm sharing it with you such that you know in future that all the marks are allocated in terms of the F sort in physics. What does F sort say or mean? F sort basically says you get a mark for the formula, you get a mark for the substitution, you get a mark for the answer with the correct SI unit. So answer plus SI unit. The D is for direction when we are working with now in paper 1 your scalars and vectors. So it will always be in this sequence. But for chemistry now, for paper 2, it's the formula, 1 mark, the substitution, 1 mark, and now the answer with the SI unit. So there is no way if you apply F sort, you are going to lose marks in that regard. There is no way. There is no way, because this is the general principle that each and every one of us will use when we mark now the scripts. So be aware of it. Try to apply it in all the calculations that you are exposed to. Then it will assist you 100%, because most learners now omit SI units. They lose a mark also for the formula. Hence I explained this one, that we don't have this formula in our formula sheet. So if you write this, you don't get that mark of the formula. Do you see that? Thank you very much. Now let's take it up a notch a little bit. At number 3 now, the question says we must calculate the number of oxygen atoms. Calculate the number of oxygen atoms in 5 moles of oxygen. So we have 5 mole of oxygen. So obviously with this one, the intention is they want us to use the Avogadro number. Why Avogadro number per se? Because the question is clear for us now to calculate the number of atoms. But I am given now the mole, which is just 5 mole. What else do I need? I need now to use my Avogadro number, which is a constant. And where do I get that? I get that now from the periodic table, not the periodic table, but the data sheet. It's just 6,02 multiplied by 10 to power 23 to power 23. And this is now per mole. So I'm going to apply F sort also. Applying F sort says N is equals to N over NA. I am not going to manipulate the formula, but I'm just going to write it as it is from the formula sheet. Then I have moles, which is 5, and I want the number of moles, number of particles or atoms, Then this will be 6,02 multiplied by 10 to power 23. Then when I do my calculations, the number of particles will be something like 3,01 multiplied by 10 to power 24. And then these are now oxygen atoms. Oxygen atoms. So this one becomes now an easy one to do because we are already given the number of moles. But let's take it a notch higher at number 3b. So at 3b, let me duplicate this quickly. So at 3b, what they do is they give us now only the mass, but the question still wants us to calculate. Let me clean up this. I will leave the F sort and everything else such that we apply it the right way. So we are at number 3a or 3b. So at 3b, they say now calculate the number of carbon molecules in 2 grams of carbon dioxide. So calculate the number of CO2 molecules in a 2 grams of carbon dioxide. In 2 grams of carbon dioxide. So now let's look into this and try to digest it accordingly. The equations I have is N is equals to N over Na. So it basically says for me to calculate this number of molecules, I must first get the number of moles. So it basically says in this one, I am going now to have a multi-step approach. Multi-step approach means now what? Using 2 equations to solve a specific problem. Because I don't have the number of moles, but I am given the mass. I must first now get the number of moles. After the number of moles, now get the number of particles. So these are types of questions that the examiner asked. These are type of questions that when we sit down and analyze papers, we look into our learners able to perform a multi-step calculation. Because with a multi-step, it basically says N is equals to what I need to calculate. Mass is now given as 2 grams. I must now be in a position of calculating the molar mass of carbon dioxide, which will just now be 12 plus 2 multiplied by 16, and we said this will give us 44 grams per mole. So with this information given, can I calculate the number of moles? Yes, I can. It will be N is equals to M over M, which is just now 2 divided by 44. Then I will get my final answer as 2 divided by 44. This will give me something like 0,04545 mole. So this is my first step or approach. So the second approach will now be, let's use the equation that relates now the number of moles with the number of molecules. Remember, we said now that n in that equation of n is equals to n over a. It basically relates to the number of particles, number of atoms, as well as number of ions or anything thereof. So I'm going to quickly write it down to say n is equals to n over Na, and I have calculated my number of moles to be 0,04545, and I want to calculate that excuse me. Then I want my Avogadro number. So my Avogadro number is something like 6,02 multiplied by 10 to power 23, and I get my n now as something like let me calculate now. It's 0,04545 multiplied by 6,02 exponent 23, and then this gives me something like 2,74 multiplied by 10 to power 22, and this is carbon dioxide molecules. So I'm going to give you something like 20 seconds for you to digest this, and if you have questions related to it or anything that we have done so far, then you can feel free to do so. So let me give you the 20 seconds for you to digest, and if you have any questions here, then you can be able to ask. Are you happy, Ratana? Okay, thank you very much. Let's move now to the other one. So with the other one, I will also duplicate this. And okay, after duplicating this, let me just add a new sheet. So from this now that we are able to use the number of moles correctly, we are able now to calculate the number of molecules. We also need to calculate the number of ions. But with the number of ions, it's something that I feel we can easily do it once everything in the topic has been done successfully or very, very clear. But I am going to do one such that I know that everything has been covered, and now you will be in a position of exposing yourself more to other different types of questions. So I'm going to write down the question here. The question says, how many hydrogen atoms are there? So this will be now number 4. How many hydrogen atoms are in 5,1 gram of NH3 molecule. So I can see my system is a little bit slow, so we'll wait for it now to respond, but eventually the writing is on our whiteboard. So let's read this question again together. How many hydrogen atoms? So we are interested in hydrogen atoms, but we are not given the hydrogen atom as a standalone. We are given NH and H3. So think of this and try to assist me in terms of how best can we approach this one. How many hydrogen atoms are in 5.1 grams of NH3 molecule? So they're basically saying to us, let's only focus on hydrogen atom. But the information given, it's now for the NH3 molecule. So how do we go about this one? So I'm going to give you now 5 minutes for you to try and figure it out, and then we will do it together once you are done. So I'm going to give you 5 minutes for this one. It's a little bit complex. It requires now us to think of how to incorporate everything we have done so far. So we are only interested in hydrogen, but the information given, it's now what? It's now for NH and H3. So I'm going to start on the timer from my side such that you are able now to follow through. So think of it, try to do it, and then we will confirm the final answer. So I'm starting the timer from my side. Don't forget to send your answer in the chat so that I am able to mark it quickly for you. Thank you very much, Ratanang, for your answer. I have just marked it and I picked up a few mistakes that you did. And let's look into the information that is given. Remember what we are given here, the 5,1 grams of NH3 molecule. That is now for NH3. So what you used only the molar mass of hydrogen, and that cannot be right. So the easiest way of going on with this one is for us to say, what are we giving? First thing, the approach is 100% correct, but there are fewer mistakes that you did. So the information given is the mass of NH3, which is equals to 5,1 grams. So check how I am writing it down, such that we can know what are we focusing on. So in this instance, we are focusing on NH3. So the mass that is given is for NH3. It's not for hydrogen. Then we move further on and say, what else am I giving here? That is the only thing, but I need now to calculate the number of moles of NH3. Can I calculate the molar mass now of NH3? Yes, I can. This will be now 14 from the periodic table plus now 3 multiplied by 1, which will just give us 17 grams per mole. So it basically says the number of moles that I am going to get will be the number of moles of NH3. So I'm going to say N of NH3 is equals to the mass over the molar mass, which will now be 5.1 divided by 17, which will give me, let me use my calculator, 5.1 divided by 17, this will give me something like 0.3 mole. But this now is the number of moles of NH3, not hydrogen, not nitrogen, but for NH3, because the information given, that mass that is given, is the mass of NH3. So I am not in a position of singling out N or for nitrogen or H3 for that matter. I need to be consistent in terms of the information that is given. So with that being given, it says to me, now that I have the number of moles, how many atoms of hydrogen do I have? Ratanang, how many hydrogen atoms do I have now in NH3? How many hydrogen atoms do I have in NH3? So when I look at NH3, I have 3 hydrogen atoms. So for me to get now the number of moles of hydrogen, it's easy for me to say N. It's easy for me to say N now of hydrogen is just 3 times that of NH3. sorry. And this is what now you need to get right. N of NH3. Because in one NH3, I have 3 hydrogen atoms. So it basically says to me now, for me to get the N, I must just 3 multiply by 0,3. This will give me something like 3 multiplied by 0,3, which will be now 0,9 more. 0,9 more. So the 0,9 more is basically for NH. So now that I have the number of moles of NH, it's easy for me to say N now of that is equals to 0,9. I want now the number of hydrogen atoms divided now by my Avogadro number 6,02 multiplied by 10 to power 23. Then I do the calculation. That will be now 0,9 multiplied by 6,02 multiplied by 10 to power 23, and this will be something like, let me quickly use a calculator, 0,9 multiplied by 6,02 exponent 23. This will give me something like 5,42 multiplied by 10 to power 23, and these are just now hydrogen atoms. So I'm going to give you 30 seconds again for you to ask your question, and maybe if there's a clarity seeking question on this one, don't feel shy, just quickly ask your question. I'm giving you 40 seconds for you now to digest this one, and then you can ask your question. So I hope we are still together, such that we are in a position of fully understanding each other. So I am going to start the timer. Okay, you just need to check what molecule are you given. For instance, let me try to write down something like CO2. Ne? So if you are given CO2 and they want you to calculate for carbon, you don't need to multiply, because it will be one of everything that is given. Ne? So, but if they ask us, let me change a pen. If they ask us now to use oxygen, for oxygen, obviously I have 2 atoms because it's CO2. Ne? Yes, so for carbon, I will not need to multiply, but for oxygen, definitely I must multiply now with 2 because I have 2 atoms more than the carbon itself. So the reason for us here to multiply by 3, it's because we have now how many hydrogens in NH3? We have 3 hydrogen atoms. So just check what is it that the examiner is asking for. So if the examiner is asking for O2 in this example of mine, then definitely you must multiply by 2. If they are only asking for carbon is just only 1 carbon. So it means this carbon will be equals to whatever we have, because everything multiplied by 1 is now that number. Thank you. So now consider the issue of the molecule you are working with, because in this instance the focus was on hydrogen atom. So but if the focus now was just on nitrogen, then there was no need for us to multiply. So with that being said, it says to me, can we do a little bit of another one where we focus in terms of calculating the mass, but we are giving now the number of atoms. So let me add a new page. Let me add a new page. So adding a new page, the question will be, calculate the mass. So that is now at number 5. Calculate the mass of 1,806 multiply by 10 to power 24 of carbon atoms. So I'm also going to give you 5 minutes for us now to try and do this one together. Remember to send your questions also, or your answers, so that I can easily see what is it that you have done. So with this one, the idea is we are moving from, remember this one, we are given the mass, we want to calculate the number of atoms or molecules. So with that one, we are given now the number of atoms. We want now to move to calculating the mass. So it basically says it's the reverse version of this one that we did at number 4. Remember, the key idea for me is I want now to close all the gaps in terms of ensuring that every simple basic issue has been addressed and attended to. That is how you get your maximum marks. So let's try to do this one together. I'm going to put down a timer also for 5 minutes, and then we can be able to start. Thank you very much, Ratanang. Are you done with it? Okay, thank you. Okay, thank you very much. I have received it. Let me quickly look into it. Okay. Okay, I have sent you your response. Remember, ne? Hence, I always say the approach is 100% correct. But now let's look into the information that is given. I am given N for copper, which is equals to 1,806 multiplied by 10 to power 24 atoms. But now I must use, remember, my Avogadro number. So the Avogadro number is equals to 6,02 multiplied by 10 to power 23 per mole. So this is the mistake that you did of not using the Avogadro number, because we cannot use 22,4. We are not working with a gas, but we are working now with atoms. So once you get that one right, that this is the number of atoms, so it being the number of atoms, it allows us now to only speak of the Avogadro number. Kindly open your mic. I want us to go through this together. Now, remember in your answer, you gave us 22,4, ne? So the 22,4 is now when you have that Vn. So in this case, we cannot be using the 22,4. So that is now one mistake that you did. And because of that, now everything else becomes now incorrect. Hence, the key idea is write down the information that is given. The approach is correct, but the mistake that now makes us not to achieve the maximum marks is we used now an incorrect constant value. So remember, once it says now atoms, definitely we associate that with the Avogadro number. Okay, thank you. So let me further move on to say now this should be N is equals to N over Na. And now the number of moles is what I want. 1,806 multiplied by 10 to power 24 divided now by 6,02 multiplied by 10 to power 23, and now this will give me something like, let me use my calculator, 1,806 exponent 24 divided by 6,02 exponent 23, and this gives me now just 3 mole. But this 3 mole is now for copper 100%. So now that I have the number of moles, how can I relate the number of moles with mass? The equation that I have is M over the molar mass. So I have 3, which is equals to now what? Mass is what I am looking for, and this is just 63,5 from the periodic table, and then I can get my answer as something like 190,5. 190,5. So this will be equals to M of copper will be just 190,5 grams. Definitely, this is the right approach, because now I have moved from being given the number of atoms into getting the number of moles, from the number of moles into getting the mass. So this will be plus minus 5 marks in an exam, or even 6, because it will be 1, remember F sort, substitution, number of moles, and maybe substituting there this one and the final answer. So this will be plus minus round about 6 or even 5 marks. But okay, this will be now for the formula, not for this, because we have already allocated a mark for that. So the intention is, if these basics are closed or have been attended to, we will be in a position of moving further up. So we have used go to this one. We have used this one a couple of times, very happy with that. We have used now this one, which is number 2, very happy with that. So we tried now to try different dimensions, different angles of how the examiner can ask now these particular questions. So because of that, now it basically says in our second session, we'll move now into number 3, number 4, and introduce percentage composition as well as the empirical formula.